Okay, so I'm just going to go through a couple of these questions. So the first one is to complete and balance the following equations. Over here we have butan-2-ol. So the first thing we need to identify is that this is a secondary alcohol. Okay, if we classify what type of alcohol we've got, we then know what type of reaction it will undergo. So this is a secondary alcohol. It's got an oxidizing agent present and it's undergoing reflux. So for a secondary alcohol, if we do the oxidation under reflux, it will form a ketone. So the ketone that this will form looks like this. So remember, the alcohol was on carbon number 2. So if I start numbering from here, it was on carbon number 2. So that means your ketone functional group must also be on carbon number 2, like so. And these other hydrogens go back in, but just make sure that this carbon here doesn't have any hydrogens on it. So this here is the ketone that is formed. If this was butan-2-ol, this ketone is called butan-2-one. And the other product that is formed is water, and just double check that it is balanced. It's usually the number of hydrogens that you need to double check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 2 oxygens on this side, 2 oxygens on that side, and 4 carbons on each side. So that is the correct balanced equation for this reaction. And we would observe a colour change from orange to green. Right, down here we have propan-1-ol. So the first thing we need to identify is, or the first thing we need to do is classify this alcohol. It is a primary alcohol. It's undergoing distillation, and therefore a primary alcohol is converted into an aldehyde when undergoing distillation. So if we've got propan-1-ol here, the ketone, the aldehyde that will form, so aldehydes are always at the end of the chain, so it's got to be on this side. So we have our carbon double bonded to the oxygen and a hydrogen coming off that. So this is the aldehyde functional group. And everything else goes in like so. And if this over here was called propan-1-ol, this is going to be propanal. We don't need to have a number when it comes to aldehydes. We don't need to say it's propan-1-al because the aldehyde is always going to be on carbon number 1. And the other product is going to be water. Again, just balance, double check that it's balanced. So 3 carbons on either side, 2 oxygens on either side, and 8 hydrogens here, and 1, 2, 3, 4, 5, 6, 7, 8 hydrogens here. So that's the correctly balanced equation and the correct organic product for this. Right, moving on, we have to write balanced equations with conditions for the following transformations. So the first one that I'm going to focus on is A. In terms of the functional groups, we go from a alcohol to a haloalkane. So we're basically substituting the OH with the Cl. So in terms of writing out the balanced equation for this and conditions needed for this one, so we start off with our primary alcohol, which was propan-1-ol. And if you remember, to do this substitution reaction, we need to have the sodium halide. So in this case, it's going to be sodium chloride. And we need sulfuric acid. That is going to form the substituted product. So that's going to form this chloro product here. And the other products are going to be H2O and sodium hydrogen sulfate, like that. So that's the balanced equation for the transformation of A. The next one is B, so we're going from propan-1-ol to this alkene over here. So if we're going from an alcohol to an alkene, that's a dehydration reaction. So to dehydrate an alcohol, we need specific reaction conditions. So we need to have a strong acid, so usually phosphoric acid, and we need to heat it under reflux, and that's going to form the corresponding alkene, which looks like this. And we are going to release a water molecule. Because it is an elimination reaction, we do have to end up with two products. And the last one, so C, is going from our primary alcohol to a carboxylic acid. So to go from a primary alcohol to a carboxylic acid, it is an oxidation reaction. And remember, there's two possible reaction conditions we can do. Only one of them will give us a carboxylic acid from a primary alcohol. So the balanced equation here, we reacted with an oxidizing agent, and we always write the oxidizing agent on the arrow. So it's potassium dichromate with sulfuric acid, and to get the carboxylic acid, we have to have this undergo reflux. So that's going to give us the corresponding carboxylic acid. And we also release a water molecule, and then to check it's balanced, count the number of oxygens here, that's 3, we've only got 2 here, so we need to have 2 here. In terms of hydrogens, we have 8 here, and we have 1, 2, 3, 4, 5, 6, 7, 8 here on that side as well. So these are the balanced equations for that task. Okay, next one. So it says alcohols can be oxidized using acidified potassium dichromate. Show the full displayed formula of the organic products formed when acidified potassium dichromate is heated under reflux with these alcohols. So butan-2-ol is, the first thing you need to identify is what type of alcohol it is. Butan-2-ol might help to draw it out, and if you draw it out, you should see that it's a secondary alcohol. Secondary alcohols form the ketone or the corresponding ketone. So butan-2-ol will form butan-2-one. So for A, your organic product should look like this. So if it's asking for the displayed formula, we do need to show all the bonds in this molecule, like so. B is hexan-1-ol. Hexan-1-ol is a primary alcohol, and if we have a primary alcohol and we undergo reflux, undergo oxidation under reflux conditions, we're going to form the corresponding carboxylic acid. So hex chain, like that, and if it was hexan-1-ol, it would have been coming off carbon 1, so our carboxylic acid is going to be here. Again, I'm going to show all the bonds because it did ask for the displayed formula. And then just all of these carbon hydrogens go in as well. Okay, and next one, C, so ethane 1,2-diol. So I'm just going to draw that out first. So ethane 1,2-diol is this. If we do the oxidation of this, first things first, we need to identify what type of alcohol. This one here is a primary alcohol. This one here is a primary alcohol. So that means we're going to make the corresponding carboxylic acid on each side. So this one here becomes a carboxylic acid, and this one here becomes a carboxylic acid. So we form this compound here. D is butane 1,2-diol. I'm just going to draw that out just so we can see the difference here. So 1, 2. So hopefully you can see the one at carbon 1 is a primary alcohol. So this one here is a primary alcohol, this one here is a secondary alcohol. So the primary alcohol will become a carboxylic acid, and the secondary alcohol will become a ketone. So the primary one becomes our carboxylic acid, and our secondary one becomes the ketone. It doesn't matter where you draw, I'm just going to draw at the top, and that becomes our ketone, and then everything else goes in the same way. Always double check each carbon should only have 4 bonds, like so. So that is the correct organic product for this reaction here. The next one says to write the overall equation for the reaction between butan 1-ol, sodium iodide and sulfuric acid. Name the organic product and state the type of reaction taking place. So we've got sodium halide, we've got sulfuric acid, and we've got an alcohol. So this is going to be a substitution reaction. Okay, so substitution is the type of reaction occurring. So this question 2 that we're doing. So we've got butan 1-ol. I tend to draw it out just so you can see exactly what is happening. So, sorry, you've got butan 1-ol. So this is butan 1-ol. And we react that with sodium iodide, so NaI, and sulfuric acid. So in the substitution reaction, we substitute the alcohol group for the halogen, which is iodide in this case. So we're going to form this compound here. So it doesn't matter if I draw the I here or the I here, it's still attached to that carbon number 1. And the other products, there's 2 more products as well. One of the other products is going to be H2O, and one is going to be sodium hydrogen sulfate. Name the organic product. So this one here is called, so it's a butane chain, so it's 1-iodo butane. But don't worry too much if you don't know the name of that. We haven't covered haloalkanes just yet. So 3A, draw the full displayed formula of the organic products of the reactions between the following. So propan 2-ol with concentrated sulfuric acid. There's nothing else present there, so anytime we're using a concentrated acid and an alcohol, that's going to be a dehydration reaction or elimination reaction. So that means from propan 2-ol, so where the alcohol would have been on this group, we're going to form the corresponding alkene. So this is the alkene formed by the dehydration of propan 2-ol. For B, we're reacting 2-methyl propan 2-ol with a mixture of sodium chloride and concentrated sulfuric acid. This is a substitution reaction again, so like the one we did at the top. So where we have, so propan 2-ol is that, it's 2-methyl propan 2-ol, so there's a methyl group coming off there. And the organic product is where this alcohol is substituted with, if you're using sodium chloride, it's substituted with a chloride. So that alcohol group is just replaced with a Cl. And that is the product for this reaction here. If we're talking about organic products, it's always the carbon-based compound. Obviously, there are going to be other products as well, but this is the organic product.